Okay, so we're going to learn about reflections today. So far, we've learned about dilations and translations, right?
Yeah.
We kind of learned about reflections yesterday in the video that you watched, introducing all the different concepts. So reflection is also known as what? Does anybody remember? Remember we talked about the selfie? What happens to the picture when you take a selfie? It flips, right? So a reflection is a transformation on the coordinate plane that flips a figure over an axis. The points of the reflected figure are the same distance from the line of reflection. Or the axis. Because all that we are reflecting over in this class this year is an axis. That's all. We're not going to reflect over any random line. It's just going to be over the x-axis or over the y-axis. In a reflection, the orientation changes, but the figures are still congruent. Notice how for every transformation, we're really focused on the orientation and the congruence. Those are some big rules for us to remember. So here I just want us to underline some things. I'm going to highlight them, you underline them. So reflection over the y-axis, your y value stays the same. Then your x becomes opposite. What does that mean? What does opposite mean? Tatum?
It means like it's different from the others. It's different.
Not quite. Carly?
It if it was a positive, it would be a negative, or if it was a negative, it would become positive.
Right. So if it's positive, it becomes negative. If it's negative, it becomes positive. So if we reflect over the y-axis, our y value stays the same, but our x value becomes opposite. So this is our rule right here for reflecting over the y-axis. We start with x, y, and then our x becomes opposite. Do you see how the x has a negative symbol right in front of it?
Yeah.
So example, if I have 3, 5, then my 3 would switch to negative 3 and my 5 would stay the same. Or if I have negative 6, 2, my negative 6 turns to positive 6 and my 2 stays the same. So we're not changing the numbers, we're just changing the sign in front of the numbers. Okay? So now if we have reflection over the x-axis, your x value stays the same, your y becomes opposite. So our algebraic rule for reflection over the x-axis is that x stays the same and y becomes opposite. When you see that negative symbol in front of y or x, it just means opposite. It doesn't mean negative. So if we have 7, 2, it becomes 7, negative 2. The 7 stays the same, the 2 becomes opposite. 5, negative 4, the 5 stays the same, the 4 becomes opposite. So it becomes positive. Does anybody have questions about the rules? Yes, Tommy.
Is there any kind of rule that would change both of the numbers?
No, we are only going to reflect one thing at a time.
Yes, but isn't there, I think there's something called the z-axis, right?
Not in this class.
Okay.
Okay.
Yeah, but
All right, now we're going to do example number 1. It says reflect the triangle over the y-axis. What would the new coordinates be? Make sure to plot the new points as you go. What's really important is that we plot our points first, okay? So we have, let's go ahead and label these points. Let's label them A, B, and C. And then we'll go over here and do the same. Actually, it's in a weird order, but that's okay. We're spelling back wrong. Okay. So then this is going to be B prime, A prime, and C prime. I'm like tripping over headphone things over here. Okay. if B is reflected over the y-axis, this is where we're reflecting it, right?
Yes.
So what's going to change? The x value or the y value? What's going to change, Amir?
The x value.
Right. The x value changes if we're reflecting over the y. So it becomes opposite. So now we're going to have -2, 4, -1, 2, -4, 1. So now let's plot our new graph. So we're going to have -2 up 1, 2, 3, 4. That's B prime. -1, 2. A prime. And then -4, 1. C prime. Well, those lines are a little bit weird, but that's okay. Do you see how if I'm going off of the y-axis and I'm comparing B, I go 1, 2 over here to get to that B, and then I go 1, 2 over here to get to this B.
Yeah.
So they're equidistant from the y-axis. The y-axis is our line of reflection in this particular problem. So if I wanted to count C, I'd go 1, 2, 3, 4, and then this should also be 1, 2, 3, 4. Make sense to everybody?
Yes.
All right, let's go to the next one. So now we're reflecting across this x-axis. Yes, ma'am.
So we would like change the y-axis.
We change the y value,
Okay.
not the y-axis. Okay. So again, we're gonna do A, B, C. We're just numbering them the exact same that we had before, which is actually B, A, C. Because this happens, loses it sometimes. So now we're changing the y value, right? Because if it's the x-axis, it's going to be x -y. So I change the y value. What's B prime going to be? Say it louder. 2 -4. What's A prime going to be?
1 -2.
What's C prime?
4 -2.
4 -1. So now we're going to graph that. So we're going to have 2 -4 is B prime. 1 -2, whoops, A prime. And then 4 -1, C prime. So then once again, if we check our answers, A, we go up 2, then for A prime, we should go down 2. C, we go up 1. C prime, we should go down 1. So they should be equidistant from the x-axis. I want us to go back to example number 1 and write -x, y, so we don't forget the rule for each. Does anybody have questions before we move on? All right, awesome. Now we're going to do the practice problems.